Hello. So today, um, my name is Fatih, and this is my final project for CS 4632 Modeling and Simulation at Kennesaw State University. Today, I'll walk you through the traffic simulation I built in NetLogo, explain how it works, demonstrate how it runs, and share some key results from my analysis. So let's not waste any time. Unfortunately, I've done a couple of runs before and the screen recorder failed on me. So I'm hoping this one is the one good time. So I'll explain um, what my model simulates and give a quick tour on and a live demonstration on my README documents on how you can also run my code and the simulation in your computer. So the simulation in my simulation, the simulation represents a simplified city and basically a traffic grid. Each agent in this model of mine is a car and they commute from home location to work location across a grid of roads and intersections. The environment includes like traffic lights that can operate automatically or manually. And what makes this simulation interesting is how each car reacts to traffic lights and other cars in front of them, and a key behavior parameter that I'm um, using to test other things is called acceleration. So at this point, I feel like we can get into how you can also run this in your computer. So for this project, I chose to go with NetLogo, which is an odd choice, you might say, but I wanted to do this for two main reasons. One is to get out of my comfort zone and explore a new development tool that would be interesting, something interesting and useful to try. And second is that I loved through some initial research how NetLogo blends variables and simulation with visual effects and being able to see what is happening, the changes you make. That was really a key factor from deterring me from running everything on Python like I usually do and going into an uncharted territory for me and trying something new. So, how can you run my code in your computer? Again, you can go to the link through the link that I've provided for you in the README document in my GitHub, which is also included, and I will go through. You can just directly go to NetLogo's website. Um, Another way to go is just if you just go to Google and write NetLogo and then hit enter. Here we can see the NetLogo homepage. If you click this link, it will send you to the same website. Let's just close one of them. And here I've used NetLogo Web and it was sufficient for all the codes and simulations and developments that I needed to do. So if we go here, we will be welcomed by this page and they give different and random models through their library each time you enter, which is cool to see more unique and awesome models they have. So we're not too interested, but it is good to see like this basic layout of things. So usually they have variables on the left side, the simulation screen on the right, and for me, I have some graphs in this like box that I'm drawing with my pointer, and the command center, NetLogo code, and model information will be is under the graphs for me. So if we, do something, as you set up things, things happen in the simulation screen, which is really cool. And I could, use demonstration, but I want to, really use my time really well. So how do you run my code? Well, we will upload a model after you download it through my sources um, branch in my GitHub. You can go to choose file, and here you will select the NetLogo code you want to run, essentially, and load into the NetLogo browser. Uh, for me, it's called test.nlogo, but it will be the fk underscore netlogo underscore code dot netlogo for you, as I will have that to be the most updated version of my code. So if you click that, but for me, I'm doing this, um, and load it into our browser. Here is the screen we get. Nothing too fancy yet, and I'll actually make this a little bit bigger. So this is what it looks like. And for my tests, nothing happens, as you can see. Like if you even if you change anything, nothing happens here. But all your um, changes take place when you hit setup. When you hit setup, you have all these, and I guess the number of cars are too big. And for my runs, actually, I've used 50 and a 3x3 setup. So this I found it to be ideal in terms of visual and in terms of the data collection, which I will show you how I've done it. So I've kept these the same. I used 3x3, 50 cars, and number of cars changed in the scenario testing, but for other testings and what I'm about to show you as like how model works and running a sample simulation, this is what it is like. So these are checked the same. They're not changed. They're the same. And here are the key metrics that I'm keeping in track of. Stopped cars, average speed of cars, average wait time of cars, average queue length are the things that I'm looking for. 3 of these 4 were built in, and I've used one of the, let me see, traffic grid goal is one of the models that I've based my code on, and most of my code comes from that. So huge thanks to whoever has designed that and thoroughly peer reviewed and tested that. So I didn't have to, go through every variable to make sure they were working. I know I had a solid start from the beginning, and I just added things that would make sense, and I wanted to the things that I wanted to collect to better my understanding of my simulation, basically. So 3x3 50, let's run something. Let's run a simulation. One thing at this point you might be wondering, well, I see all the variables. How do I change acceleration, which is the main focus of my project? For that, it is a little bit inconvenient, however, not impossible. If we go to NetLogo code and click anywhere in the code and press Control Find, Control F, we'll have this search bar, and here we'll write set acceleration, set XC is enough, and hit enter. There's only one instance in the whole code, and it is this bit in line 102. There's this set acceleration to 0.099, and 1 gets us a rounding error, so this is a good number for it. And I could have added more nines, but just ended it right here. So this is how you change acceleration, which is a little bit inconvenient, as I said before, but not impossible to do. And I was able to change it and recompile my code and then get different results very practically. So let's run with the default acceleration on, and let's run it for 500 ticks. This is just like how often ticking happens. So if you max this out, it will be like 100 ticks every second ish. And if you did it like this, it will be 1 tick every second. So it would be pretty nice to have this in the middle just so we can see how things work. Or actually at the very minimum, just so we see like every movement. So let's set it up. And as we can see, if we press go, cars will move. So this car is going this way, and when it goes there, it stops at the red lights, and they're waiting at the red light, and when it's green lights, they go. And as things are happening, so are we getting meaningful data in our graphs. And it has been only 50 ticks, and in all of my code and simulations, I've used 100 ticks. I mean 500 ticks. So I thought that was a good amount of data to collect for per test run. So I'm just gonna increase this to 500, and stop at that. And when you hit go again, it stops. So let's see. Okay, good enough. 510. I'll just use 510 for others as well, just so we can compare. So we have gathered data for 510 ticks. How do we export this? How do we make this useful? Well, here's what we do. For one thing, for a quick visual comparison for myself, I just took a screenshot of like all the graphs with the acceleration being seen as well in my Word documents, and I'll upload those in the docs branch of my GitHub as well, just so I could visually compare. Okay, they make sense. More acceleration, faster average speed of cars there are. But for getting into data analysis, that's obviously not the best way. But if you click these three lines, you have a bunch of options as to how you can save these. I've saved all of these as CSV documents, and then I've used a Python script and pandas in that, to be more exact, to compare and contrast the differences between things. And I use matplotlib for plotting those into bar charts, and that's how I've collected my data. And just so we're getting to closing, just because I'm over my time limits, I'll briefly go over my not so finalized GitHub. So here, README is essentially some of the documentation, and how to run is more so in tests as well. There's a README, or not in this one, I guess in another branch, which let's make sure that I have it. Or if I don't, yep, to run NLogo code. This is essentially the beginning of this video where I explain how you get there and how we do things. So yeah, pretty much sources have my code sources. Documents are just the all of the documents that I've used throughout my journey of developing the simulation and using the codes to generate data, meaningful or not meaningful. Not all the data there is used in my milestones, and they haven't made it to reports, but they are great to see, to explore what has worked, what hasn't for me. And they've been a great source for like, okay, things are happening and I'm able to see change. And test data is basically most of these are test cases that I've run, and I believe when I click this it will download, and that's also fine. I can just, okay, that's fine. And if you want it to be raw, it will, that's fine. Let's put it on downloads. Let's just open it up, and we'll see how I've documented my test cases, for example. And while that is taking its sweet time, I also have the CSV files of all the graphs incorporated in my tests folder. So yeah, varying acceleration and keeping these the same, as I've said above. And most of the time what I've done is just took a screenshot, 500 grid, and what they look like, and I just compared when I change acceleration, was there a meaningful jump, which when the acceleration was hugely a difference, there were, and when it wasn't, there wasn't. So it was sometimes hard to tell, and sometimes it was very obvious, and that's just a way of how I did things. And I am almost at the 15-minute mark. So I'll just, some closing remarks, I guess. Thank you for watching my project demonstration. And as I've said, all source code, charts, and analysis are going to be included in the final report and GitHub repository. I just want to say, like, this was a great opportunity to explore agent-based modeling and its real-world applications. And I'm happy that I get to do this. Thank you so much.